keynote speaker for this session is Dr. Rajashekara, did I say that correctly, from the University of Houston. He's a distinguished professor and professor of subsea power systems in the College of Engineering. He has a PhD in electrical engineering and an MS from the Indian Institute of Science in Bangalore, as well as an MBA from Indiana Wesleyan University in Indianapolis. He has a number of research interests, including subsea electrical and power electronic systems, fuel cell-based power generation systems, and a number of other areas. And today we'll be talking to us about advances in transportation electrification.
Okay.
Please.
Thank you very much. Thank you for inviting me to speak in this conference. So my topic is on advances in transportation electrification for carbon dioxide emission reduction. I spent about 17 years in General Motors in Delphi on electric and hybrid fuel cell vehicles, and 6 years in Rolls-Royce on electrification of the aircraft. So and then afterwards I continued some work in these areas. So all these I'm trying to put together in this presentation. So I'm going to cover about some of the problems related to emission problems related to transportation, electrification of automobiles, like and electric and hybrid vehicles, electrification of aircraft, electric and hybrid aircraft, vertical takeoff and landing vehicles and flying cars, and marine transportation electrification, and conclusion. So that is it, and it is almost 1:23, so we have about 40 minutes time. So U.S. greenhouse gas emissions by economic sector, if you see, transportation is the largest. Almost 1/3 of the emissions are from the transportation, because the number of miles we are driving is going up. And the United States, we consume about 20 million barrels of oil per day. So the world consumes about 90 million barrels, 93 million barrels of oil per day, and we consume about 1/4 of all the oil in the United States. So, and when a car burns, 1 gallon of gasoline is burnt, 19 pounds of carbon dioxide is emitted. So on an average, an automobile produces about 5 metric tons of carbon dioxide per year, between 5 and 6, depending on the car. Even in the airplanes also make a lot of emissions. The airplanes contribute 9% of the transportation emissions. So light duty vehicles are responsible for 60%, and heavy duty vehicles like trucks, they are all about 23%, and others rest. But the aircraft is about 9%, and twin aisle vehicles like 747, 777, they are all twin aisle airplanes. There are 2 aisles, twin aisle. So they contribute for 50% of the transportation emissions due to the air transportation. Okay. So more than 90% of carbon dioxide emissions from global commercial aircraft operations are generated by large aircraft. This is from the inventory of the greenhouse gas emissions, that report. And also from, there is another report called National Academy's report, 2015. And an APU in an airplane, APU, the auxiliary power unit, that is the one that is required to generate the electrical power. It drives a generator and produces the electrical power. So APU is not the one that produces the, provides the main propulsion for the aircraft. Even one APU in 777 produces emissions equivalent to 155 automobiles like Chevy Impala vehicles, big cars, okay? That much of emissions, one APU. Marine is also makes a lot of emissions. Say, for example, a container ship makes equivalent to 75,000 cars of carbon dioxide. NOx 2 million, it is equivalent to 2 million cars, and PM, particular matter, 2.5 million cars. Offshore supply vessels, 6,000 cars equivalent. And so 75,000 cars, you have to put like that, that is equal to carbon dioxide of one container ship. If you make it hybrid, then a hybrid tugboat is only 400 cars, carbon dioxide equivalent. So there are a lot of emissions from the sea transportation also, but they are not that much controlled. But in April 2018, the International Maritime Organization announced a strategy to reduce the carbon dioxide emissions by 40% by 2030 and 50% by 2050. So there are regulations coming in all types of transportation. So what is the way we can reduce the emissions by transportation? That is the electrification. Electrification is the main way to reduce the emissions from transportation. And many people question that, can you reduce really the emissions from just by electrifying? Yeah, of course, it may not be 100%. Significant amount of carbon dioxide can be reduced if you go for electricity. There are a lot of studies by EPRI and NRDC reports. This report is available. You can download it using Google. So environmental assessment of a full electric transportation portfolio. The report finds that greenhouse gas emissions from light duty vehicles could drop as much as 64% below today's levels if it is electrified. And even Volkswagen, you know Volkswagen, everybody in this country now because of the diesel problem, but they commissioned a study. They also found out that for the same vehicle models with different powertrains, the carbon footprint of the battery powered electrical variants is already better than those of the corresponding vehicles with internal combustion engines. The electric vehicles offer a higher carbon dioxide saving potential in all phases of the product cycle. So, lot of studies, these are only few. ID Tech is another website. You can go to ID Tech website, you can find a lot of studies. So if you look at the how the electric vehicles are coming up, gradually the electric vehicles, plug-in hybrid vehicles, and fuel cell vehicles are replacing the internal combustion engines. The study finds that, but for example, 2050, there will be more electric vehicles. BEV 100% means battery electric vehicles. And in the meanwhile, there will be a lot of other types of vehicles like PHEV, plug-in hybrid vehicles. 20 means 20 miles of electric vehicle range operation. For example, I don't know how many of you own Chevy Volt. Chevy Volt goes 55 miles of electric vehicle range. Prius Prime, 25 miles, 25, 28 miles. So PHEV 40, that is 40 miles electric vehicle range will come, and later on PHEV 60 will come. And in the long run, we don't need any PHEVs at all. Electric vehicles will do because our batteries are improving a lot. Lithium-ion batteries with lithium air batteries, solid-state batteries, and yesterday people were talking about flow batteries. For everything together, we don't need all these hybrid vehicles at all. And if you charge all those batteries using renewable energy instead of coal or natural gas, then nobody can argue that your electric vehicles are not helping to reduce the emissions. Because if you charge from wind and solar, which is renewable energy, and you charge all those batteries from those energy, okay? And the vehicles, the study also find that fuel economy also is getting better, not only from the PHEVs, for the light duty vehicles, even for the trucks. For example, this is for the passenger cars. This is the fuel economy, that is 60 miles per gallon. Conventional passenger, this is for conventional passenger vehicles, is somewhere here, and for the dotted one, PHEV passenger car can go up to 65 miles per hour. And again, 2015, the conventional cars, it is not that 100% conventional cars will go away. So even those technologies are improving. By 2015, say they are putting greenhouse gas emissions, carbon dioxide per mile. that is grams 350, but by 2050 it is going to go down a lot, and with the plug-in hybrid or a this is the plug-in electric vehicles, means it can be hybrid vehicles or electric vehicles which are plugged in, and transportation emissions are going to go down by 2050 by electrification. Okay. So now the trend in transportation, because of all these advantages of electrification, so everything is going electric. Cars, big buses, trucks, even semi-trucks, and Elon Musk is working on 600-mile range clean energy for electric semi. Nice looking car. And airplanes, and plug-in airplanes, plug-in electric airplanes, plug-in hybrid vehicles, plug-in electric airplanes, ships, all those things. Okay. So the electrification has not started yesterday or today. It has been going for a long time, starting from radios in 1946, but recently it has taken a lot of importance because more and more loads in an automobile are going more electric. For example, we have everything is going electric. I will show you the next slide. So where is the focus? We are working on electric powertrains, hybrid powertrains. In addition to the propulsion, we also work on steering, power steering, throttle by wire, roll by wire, steer by wire, brake by wire. All those things have been happening for a long time. And then we went to the propulsion, means adding more and more hybrid vehicles and pure electric vehicles like that. Then in future, it will be more BEVs or battery operated electric vehicles, and then connected cars and all the autonomous vehicles. That will be the future. So this is the more electric automobile. Here the propulsion is still internal combustion engine, but you see everything is electric otherwise. Electric power steering, electronically controlled suspension, automated gearbox, electric air conditioning, electrically heated catalytic converter. Many of the cars which are on the streets today, they have all these features. So on a small electric vehicle, small vehicle like Toyota Corolla, which is an internal combustion engine based vehicle, is 1.2, about 1 to 1.2 kilowatt of power for all the accessories. Some bigger vehicles have 2 to 3 kilowatts of power because a lot of things they need inside the car, like entertainment system, charging, sometimes even the coffee maker, or plug in the air conditioning unit and all those things. But that is without the propulsion itself. But the future is all electric vehicles. So I think you all know what is an electric vehicle. I'm not going to take a lot of time. An electric vehicle, 100% propulsion by the electric motor. You need a battery, and there is a converter here. Why the converter? Because the battery voltage and inverter voltage may not match, so we need the converter here to match the battery voltage to the inverter voltage. And the motors, every automotive company except Tesla has permanent magnet motors. Tesla in Model 3, the recent one, that is permanent magnet motors. Tesla was the only one using induction motors, and rest of all the companies were using interior permanent magnet motors because they are very efficient, high torque density, high power density, all those reasons. Okay. And so where did the electric vehicle started? Of course, electric vehicles were there for more than 100 years. Early 1900s, there were 4,000 electric vehicles in New York and Chicago and many other cities. Yeah. But once the gasoline-based vehicles came, all the electric vehicles disappeared. But there was always a research work going on electric vehicles. Till 1990, it did not take off. When GM came with this Impact, many of you don't know that, may not know Impact. Impact is the prototype of the EV1. I think many of you, at least a little bit senior generation, they know EV1 that was sold in California or leased, I would say, because I worked on this vehicle. That's why I know. I always bring it here. So this is the vehicle. Those days we didn't have IGBTs, which are readily available now, all using silicon carbide devices. We worked with the AeroVironment. There is one Alan Kokoni, he designed the inverter. So it was based on the induction motor. Actually, this induction motor design is the one that is used in Tesla cars, because the person who designed that induction motor, he also designed it, originally designed it for Tesla vehicles. That is why Tesla still uses induction motors. So the impact, this technology was very good, and it was shown in Los Angeles Auto Show, and the GM president or the chairman announced that we are going into production. So then in 1996, this EV1 came. EV1 is entirely electric vehicle. So this is the first electric vehicle that was built as an electric vehicle, commercialized electric vehicle. Before that, for 100 years, there were a lot of 1 or 2 demo vehicles like that. So that is why this has a lot of significance. This is based on an induction motor again. So induction motors, and this was sold till 97, 96, 97 are sold or leased. And in 97, Toyota Prius came. Prius is the hybrid. And it was giving 55 miles. And this had only 80 miles range, 55 miles per gallon, 50 miles per gallon. It was giving hybrid. So there was less, then again the interest in electric vehicles died down, because everybody was jumping into hybrid vehicles. So till Tesla came in early 2000, brought this Roadster. It's a very nice luxury car, $100,000 or $110,000 it was costing, but many people bought this vehicle. Relatively a lot of people, they bought this vehicle, and they were the first to use the lithium-ion batteries. So there was no lithium-ion battery technology was still not developed at the time. But what they did is, they took the computer batteries, laptop batteries, put them in series and parallel, 6,831 lithium-ion batteries they put together, and then made a battery pack. Even now they use a similar technology, even model Tesla S, they use a similar technology. So, and that had 220 miles range, so that was very good for having paid $100,000. And so from there, then the next one they brought Tesla Model S, which is still available now. So that took off really well, even though that was also expensive, but lot more people bought the Tesla Model S, because they also brought superchargers. You can charge very fast, and it has a 10 kilowatt capable onboard charger, and they also started establishing the charging stations, Tesla. So that's why that range anxiety and all those things have reduced. And it is a very, very good technology. That technology is all with IGBTs, lithium-ion batteries, and with 85 kilowatt hour battery, they could go up to 300 miles. Okay. And now there are plenty of electric vehicles. We don't even talk about range and all those things. People just, if they want to buy, they just buy. Every automotive manufacturer has an electric vehicle now. You can buy from GM as a Volt, Nissan Leaf, Tesla for several models, BMW, and everybody has an electric vehicle. And electric vehicles have become so much. Every day I get a newsletter. You can charge EVs or Green Car Congress. There is so much news about the electric vehicles. Oh, the Karma, then Faraday Future, they changed the name to something else now, starts with C, Kalos or something, because they had a money problem. And so there is a lot of work going on in the area of electric vehicles now. And in China, so many automotive companies are manufacturing electric vehicles. In Shenzhen and many other cities, they have electric taxis. So electric vehicle has become so common. But range is a problem. Still means if you have to go from Boston to Houston, even Washington, it is a problem. So then also there is a lot of work going on the electric buses also. For example, Mercedes-Benz is doing a lot of work, and even many countries, India has announced replacing the diesel buses with electric buses, and even fuel buses, fuel cell buses. I don't know whether this works or not. Can you click on this link? Yeah. So this one, see this they are big truck. This is a fuel cell truck. So there is a lot of work going on the fuel cell. You can, that's enough. Yeah, close it, yeah. Yeah, that's what I mean. That is what I mean. Not to reduce the volume, just to close it. So now there is still a lot of work going on in the hybrid vehicles also. There are different types of hybrid vehicle technologies. You can buy a micro hybrid, mild hybrid, full hybrid, there is a parallel hybrid or range extender vehicle, electrically extended range electric vehicle, or with then full series hybrid vehicle, fuel cell vehicle. So many types of vehicle technologies are available. Yeah, briefly, we have a micro hybrid. So this one, yeah. So here it is a micro hybrid. Micro hybrid is nothing but a start-stop operation. For example, if you want to stop at the signal lights, what do? You stop, hold your brake there, and wait for the signal to turn to green, but the engine is still running. But with start-stop operation, the engine is, you can turn off the engine only when you put your leg on the accelerator pedal, then the car will move. So what is the technology? The alternator which is in the car, that is used on the electric motor also, and then it is used for starting the engine. That is the start-stop technology. Then mild hybrid. Mild hybrid is another one where you can get some power from the electric motor to accelerate the vehicle, to pass the vehicle or a hill climbing, and also you can have regeneration. Full hybrid is like Toyota Prius. You get the power from the engine and the electric motor equally, or sometimes you can use it as an electric vehicle only, and pure electric vehicle. They are all parallel architectures. Parallel. And the series one is, a series hybrid vehicle is nothing but an electric vehicle. The propulsion is provided only by the electric motor. Okay. But again, there you can have a different types of the size of the battery and the generator. In series hybrid vehicle, there is a small engine, and it is connected to a generator. And whenever the battery charge falls below a certain level, then you can turn on the engine and it will charge the batteries. So that is the series hybrid vehicle. And you can have a full series or a range extender. There are various versions. Or you can, instead of an engine driving a generator, you can also have a fuel cell. So these are the various architectures. I will skip, and so these are the various functions. And another one is the plug-in hybrid. Plug-in hybrid is you can charge the vehicle in your garage, and then when you next day morning when you go to work, you can operate the vehicle as a pure electric vehicle. That is the plug-in hybrid vehicle. For example, Chevy Volt is a plug-in hybrid. Prius Prime is a plug-in hybrid. There are other companies are also making that. So this is the, I am not going to details, this is the Toyota Prius architecture. And in Europe, Euro 6, they want to reduce the emissions, the carbon dioxide, 95 grams per kilometer by 2020. So what they are doing is they are using a 48 volts based system in the vehicle, so that you can put a bigger alternator or a bigger alternator in the motor, so that you can use it also for starting and start-stop operation, because it is less expensive by converting that existing alternator to motor, it's a lot less expensive than putting the whole hybrid. So, and also existing cars can be converted into 48-volt system. Actually, we saw Professor John Kaushik here, I don't know, in MIT, the electrical engine department. He started a consortium for automotive systems in early 2000, 42-volt based system. Then a lot of automotive companies were interested. They were all meeting here, even we used to meet every 4 months here. And then interest died down, but recently Europe started working on 48-volt system. Maybe they didn't want to go 42 volts, otherwise they have to pay a lot of money to Professor Kaushik here. So this is the flywheel system star. They can use the existing belt or they can put the motor and the generator in the same transmission for a 48-volt system here. So this is the plug-in hybrid vehicle. I told you already the Chevy Volt, and Chevy Volt architecture, it has 2 motors, 2 inverters, 2 planetary gear systems. It's a very complicated system, but it is a very good electric or plug-in hybrid vehicle, and you can go 420 miles with 1 tank of gasoline, and on an average 106 miles per gallon. Okay. So these are the different architectures like series and series parallel, and another one is, for example, most of the vehicles operate like this. They start with the battery. So as a pure electric mode, when the vehicle accelerates, then the engine will come into picture. Engine and the electric motor will provide the power, or the engine will charge the batteries and also provide the power to the wheels. And then at high power, or when it has to go for high speeds or climbing the hills, the power is coming from the battery and also from the engine. That's how it works. So with this one, I want to give you an idea about what is happening in the airplane. I remember that more electric automobile, I said earlier. So there is a more electric aircraft. For example, Boeing 787 is the first major commercially available more electric aircraft. When I say more electric, the propulsion is still provided by the conventional engine, jet engines. Inside everything is electrified, like de-icing is electric, galley loads are electric, environmental control systems, air conditioning and pressurization, they are all electric. Okay. So everything is electric there. There is no bleed air. Bleed air is the one that is used for air conditioning, everything. They are all no bleed air, only electric. And inside the power, 1450 or 1.4 megawatts, 1450 kilowatts. That is the power that is used in 787. They have Rolls-Royce, of course, General Electric Gen X, one of them, depending on the airlines. 2 engines, each engine drives 2 generators of 250 kVA, and APU is 2 generators of 225 kVA. Okay. Airbus 380 system is also more electric, but the power is only 680 kVA. They are not as much pure electric as 787. So the Airbus has a 4 Trent 900 engines. Each engine drives a 150 kVA generator, and also there is an APU, and a lot of items are electric inside, but propulsion is still provided by the engine. But whatever I said, the architecture, different architectures earlier for the automotive systems, electric and hybrid vehicles, they are equally applicable for the airplanes. Now, this work is relatively new in the aircraft industry. For the last 5-6 years, I would say it started this hybrid, and NASA looked at about 10 years ago on the series hybrid type of architectures. I will show you. So this is a series hybrid, series hybrid similar to what I said for the automobiles, parallel hybrid, series parallel hybrid. This is a turbo electric or partial turbo electric. There are various combinations of architectures. For example, this is a parallel hybrid, similar to what I shown earlier with the motor and a motor, engine and transmission. They are all on the same shaft. Here it is all on the same shaft, turbofan, electric motor, the battery, the fuel comes. or this is a propulsion. This is like a series hybrid. The engine drives a generator, generator provides the power to all the electric motors, and instead of having 2 electric motors, you can have over 20 electric motors or 14 electric motors or anything you can have, or you can have turn off during the cruise or descent, you can turn off some of the motors. So that is the advantage. So possible future commercial large transport aircraft will be like this. This is the series hybrid vehicle, and this is a parallel hybrid vehicle. I will show you more about this. This is the NASA has been looking at it for the last 10 years. So you mount the engines on the tip of the wing and put the electric motors here, and the engine will drive the generators. The advantage is you run the engines only at a fixed speed. So that makes it more efficient. So then electric power is provided to all the propulsion motors. And here we are talking about 30 megawatt generators, and each propulsion motor is about 5 megawatt. 5 megawatt propulsion motors. There 35 is the generators. It's 3 megawatts here. And also NASA was thinking about cryogenic cooled system for this type of thing, because otherwise motors are quite big. And we also worked when I was in Rolls-Royce and the architectures for this type of vehicles, using how do you protect, that much power means you need to do. So we were looking at superconducting fault current limiters, different architectures and all those things. And this is the turbo electric propulsion roadmap for NASA. And this is already nearly 8-10 years old, so we don't know when there will be a pure electric or even a hybrid electric aircraft. But there are other companies like Zunum Aero is looking at hybrid electric aircrafts. For example, by 2027, they want to have a 50 to 60 passenger hybrid electric aircraft. By 2030, about 100 passengers. So there is a lot of work going on by different companies. Airbus, Rolls-Royce, Siemens, they are all teaming up to develop another electric aircraft. What they are doing is they are taking an aircraft with 4 engines and replacing 1 engine with a completely electrical system, electric motor, electric generator, and the power provided by the engine driving the generator for demonstration. So this work is going on. And even British Aerospace, Farad Air has revealed its intention to certify its revolutionary 18-seat hybrid electric aircraft. So they are working on it. NASA is, of course, there is a bigger airplane. They are looking at a smaller airplane for pure electric now. Pure electric, but this can run for about 30 minutes. So they are looking at pure electric aircraft. And problem why we cannot have a bigger pure electric aircraft, this is done by the Boeing, the study. If you want to replace a 737, 5 million pounds of batteries you need, that is equivalent to 29 aircraft powered by jet fuel you need to replace batteries. So it takes 5.5 million pounds of battery to reach the same energy as 60,200 pounds of jet fuel that is used in 737. So for example, 747, 45,000 gallons of fuel, 777 has 37,000 gallons of fuel, Airbus 380 is 310,000 liters in 5 minutes. Okay, so a lot of things are there. So that is why even Boeing 777 to electric, it is not easy to convert. I have made some calculations here. So it is. And there is other work is going on is how to make the engine itself more electric. Right now, all the engines have low LP shaft, HP shaft. They all drive a gearbox, and there it is mounted the fuel pump, hydraulic pump like this here, hydraulic pump and others. So what we are looking at is to make it more electric. Everything, hydraulic, oil pump, fuel pump, hydraulic pump, everything driven by the inverters, and generate the power from the shaft. So directly from the shaft, mount the, like here, so mount it directly on the shaft, no gearbox, that is one, but there is no commercial aircraft right now. So there are a lot of architectures. There are no commercial aircraft right now. These are all for the future. So in my future talk, I can present it as the present one now. And we were also looking at converting, putting the APU. APU, I said, it is a very inefficient and how much? 15% efficient. So we were thinking of putting a solid oxide fuel cell and a hybrid APU and combine both of them for 787 airplane like this, but technology is further away. So this I will skip. There is a lot of work going on flying cars. Flying car is a little bit misnomer. Everybody calls a vertical takeoff and landing vehicle as a flying car, but they are all VTOL vehicles. For example, this is a VTOL vehicle, but somebody asked, they call it a flying car. That is not. There is a lot of work. Take for a air taxis. Uber is working on these things. There are so many companies like Joby, E-Hong. E-Hong demonstrated in Dubai that as a air taxi. Terrafugia, local company founded with the MIT graduates. They are working on this Terrafugia TF2. It is not as exotic as the one they were trying to work earlier, TFX. I want to show that video instead of this one take. It is a nice idea. You can go to YouTube and watch the video here. That is, they take the passengers from the neighborhood and go to some small strip and it will take off, vertical takeoff and landing. It is not exciting as this one. If you can play this video, that is the future. That is what we want to have. This is the real flying car, but I think they stopped working on this one. I made more promotion of this vehicle, even Terrafugia did. All over the world I presented, this is the vehicle we need to have, but can you give the volume? Yeah. So this is from the MIT graduate. Actually, MIT graduates, they founded in 2006, and it is somewhere here, about a few months. You know where this company is? Somewhere here, right? You don't know. It is just a few minutes from here. And but that company is bought by Chinese last year. Maybe the Chinese stopped this and moved to that one, I don't know. This is the future of the vehicle. Why I like this vehicle are the flying cars. And I have a paper also on this flying car. If you have a flying car, you can skip the whole infrastructure. You can move the people without any having, you don't have to worry about construction of the bridges, you don't have to worry about destruction of the forest. So think about what happened to the cell phones. Cell phones have changed the way people work. Previously in India, for example, many of you are from India, we used to wait for 8-10 years for get a landline. When the cell phone technology came, even if everybody has a cell phone there. So as you forget about the cost, if you give it to implement this in Africa, then we can save all those safaris, beautiful things. Africa is still not developed with road-wise. I think instead of they becoming like China, China has so much of roads now. If they start building roads like what China has done in the last 20 years, then so much of environmental effect will be there. Instead of that one, we should have flying cars in Africa. That is where we need to start. Then we save a lot of things. Yeah, you can. So, I think there, one more. So there are a lot of flying car companies are working, about 75 cars are working on this one. So 75 companies are working on this type of cars. Marine, there is a lot of work going on in the marine transportation and scanned lines. They want to make it by 2019-20 zero emission operation of many of their shipping transport or marine transport operations. So all those, I'm still an electrical engineer. If you have to have all those technologies, the enabling technologies you need to know. Power electronics, electric machines, energy storage, they're all important. So more electric is the enabling technology for power generation, energy storage, conversion and others. So there will be more and more electric aircraft. And in order to reduce the pollution, in 50 years now, we may not have many of these jet engine driven airplanes. For example, there is no need for 780 or 787 or 380 and all those airplanes, because why do the generation 50 years from now think that, why do these people who are going to one place traveling with 300 other peoples or 300 other passengers, then they will think they must be crazy or very backward in technology. So in 50 years from now, there won't be any big airports, there won't be any major airplanes. What will happen is flying cars with smaller airplanes like Cessna Citation 10 and all those things. Go to a small strip like that, they can take off from there vertical and go anywhere, and you just go 10 to 12 people can travel. So no need for bigger airplanes like 747, 787, or even 747 like that. So there is a lot of work going on in the area of electric and hybrid vehicles, and of course, they are all limited by the batteries, electric motors, and power electronics and others. These technologies have to develop. And any vehicle should provide significant air quality benefits when compared to the present day gasoline jet fuel powered vehicles. That is the key. Okay, thank you. I think I took exactly 40 minutes. 1:22 I started. Questions?
Question or two?
Yeah.
I'm not sure I completely agree with your last statement about getting rid of large airplanes. From a safety perspective,
50 years from now.
even in 50 years from now, if you look, there's a very strong correlation between the size of an aircraft and its safety. The most dangerous are the ultralights. The safest ones are the largest ones. And so for any long transport, usually going into a larger vehicle gives you a lot more stability to atmospheric events. So even in 50 years, I'm not sure I want to cross the ocean in a little plane. I think I'd rather go in a big one.
How many Cessna Citation 10s had any accidents? Not. Citation 10 takes about 10, 12 passengers, business jet.
Deaths per passenger miles are much higher in Cessnas than they are.
Yeah, but
in
only 10 people
787.
you go there, hybrid vehicles, electric vehicles are hybrid, the fuel consumption is very low, and we all join at 10 people, friends, go there from your faculty, go there for 10 people. You don't need to go to airport driving 2 hours, 3 hours earlier. So that is what I think. And you take a flying cars and come there, park there, and take a Cessna Citation 10 equivalent to a hybrid car or electric, go to Paris and come back.
Okay,
So that will be 50 years from now.
okay.
Next generation. Do you can have, oh,
Up on the sky, it's going to be a lot of congestion, so
The
I really don't know.
oh, yeah.
What
That,
is
no,
like-
you are not the first. Every time, the last 10 years, I've been giving this type of flying car lectures. Everybody asks this question. You are not the first. If I had not asked, I would have been disappointed. If assume that there are no cars in the roads, only cars in the sky, like Ramayana time. So at that time, people, if you wanted to put the cars in the land, people would have thought, how can you have cars on the land with so many mountains, so many rivers, people are traveling and everything. It is impossible to have cars on the roads. We need to have only on the sky, you would have thought. Now we are used to it. You can have 1,000 lanes in parallel. So you can have invisible lanes.
Next speaker. Next speaker comes up against the microphone.
Yes. Thank you.
Thank you very much. Of course, you can catch you probably outside in the hallway. That's a conversation I'm sure that's going to go on for a very